Welcome to Unit 6, Lesson 5, Logarithmic Equations, Part 1. What we are going to do in this lesson is cover what is a logarithmic equation and two strategies that we have for solving logarithmic equations. Then we're going to depart from equations for a moment, and we're going to spend a couple class periods on what are called the properties of logarithms, which are properties that govern how logarithms behave, kind of like the properties of exponents, like when you can add them and multiply them, and what you do like with exponents, it's like what do you do with the exponents, and in this case it'll be what do you do with these logs when you add and subtract them and so forth. Then we're going to come back to logarithmic equations, but with the properties in play, like the second time we visit them. So the first thing we want to define is a logarithmic equation. And that's important because anytime we're solving a new type of equation, we need to be able to recognize the kind of equation we're looking at. So we might have a linear equation or a quadratic equation, a cubic equation, a square root equation. More recently, we've done exponential equations. How do you know what kind of equation you're looking at? So a logarithmic equation is any equation involving logarithms. So we definitely don't want to overthink that. And some examples of logarithmic equations might include, say, 2 log base 3 of, I don't know, we'll say 2x equals 4. Okay, and in that case, you might need to solve the equation for x. Well, I guess typically you would, and the x can be positioned in different places. So you can see the x in different places. Usually it'll be in the argument, though. It'll be part of what you're taking the log of. You could also see an equation maybe like this, like natural log of x plus 2 is equal to the natural log of, we'll say 4x. Okay, and you could see logarithmic equations that look like that, and you would not solve them the same way. So in today's lesson, we're going to cover these two strategies. How do you know when to use these strategies, and then get a little bit of practice using them to solve some pretty simple logarithmic equations. Don't expect this lesson to be a really long one. We recently came off a very long lesson on what logarithms are. And then we follow that by several ones that are shorter, which is kind of nice. All right, so there are two main strategies, and this is what I was mentioning earlier. We will introduce simple versions of these today and then revisit them again after we cover properties of logs. So today's main goal is to have a strategy in place so that you can look at the equation and say, all right, this is what I am going to do to solve it. So strategy 1 is to change the log to an exponential. We have actually seen this before. So in a previous lesson, we have covered taking an exponential and changing it to a log. So if you needed to solve, say, this equation, that is an exponential, and one of the ways we solve the exponential is we change it to a log. And so we would change this to log base 3 of 10 equals x. Well, that also works in the other direction. So suppose you had an equation that was a logarithm, okay? So suppose you had log base 3 of x equals 10. And you're like, man, I don't know how to solve that. How do I figure out what the x is? Well, you can change it over to an exponential. So this would be 3 to the 10th power equals x. And now you can solve it. So that particular strategy we have seen before, and it does work in both directions. So when you take an exponential equation as far as you can go, and you're like, I'm stuck, you can change it to a log. And sometimes the log will allow you to work the problem a little bit further. And vice versa. If you have a logarithmic equation and you've taken that equation as far as you can, you could try to change it to an exponential. And then sometimes that exponential will have some things that you could do with it that you can't do with the log. The other strategy is to set the arguments of the logs equal. And just to be clear, the arguments of the log is that part right there. Okay, it's the thing you're taking the log of. So I have log base b of a. So you can think of a, we've thought of it as a for the attic. when we're doing change of base formula, but really A for argument might be better, the argument of the log. And that you have also seen that strategy before with exponents. If we have 3 to the x equals 3 to the 5th, we have that strategy of just being able to set the exponents equal. So both of these strategies are strategies that we have seen in play before in our solving of exponential equations. So when should we use that first strategy? When should we try to take our logarithm and change it into an exponential? Well, this strategy works when there is one logarithm on one side of the equation. Okay, and we'll look at some examples of this. Okay, so we actually have, I think, 4 examples. So in each of these, what you want to be looking for is I have one logarithm and it is on one side of the equation. Okay, so not like the same logarithm. I guess we only have one logarithm. How could you have it on both sides? You know what? I think that is coming from when you have properties, because when we start dealing with the properties of logs, you can have more than one logarithm, but you can get them as one logarithm on one side of the equation. So anyway, let's take a look at this first one. So the first one is log base 4 of x equals 2. Okay, and we want to figure out what x is. And there's not a whole lot we can do with that, log base 4 of x. So some number, when you take the log base 4 of it, will give you a 2. But what we can do is change it over to an exponential. Now, if you need a little quick review on that, if you have b to the x equals n, you can write that as log base b of n equals x. Well, now we've got it in the form log base b of n equals x, and we're going to rewrite it in the other direction. So last lesson, or a couple lessons ago, we were following the arrow this direction. Now we're going to be following the arrow back in this direction. So we would have 4 to the second power equals x. Well, 4 to the second power is 16, and lo and behold, we have figured out what x is. X is equal to 16. In the next example, we would do the same thing. So we look at the base. The base of the logarithm is going to be the base of the exponential. This number over here corresponds to the exponent, and then that'll be equal to whatever it is. So we have 2 to the 4th power equals x plus 1. And now we can solve the equation from here. So 2 to the 4th power is 16. And then we can subtract 1 from both sides. And we get 15 is equal to x. As always, if you are watching this video at home, you want to pause the video and allow yourself some time to think through the concept. Don't just write stuff down so that you can produce like, oh, look, this piece of paper with like I have stuff on it. So you want to make sure that you're understanding what the strategy is and how we're employing it here. Okay, now this one has a 3 plus log base 4 of x is equal to 6. So we have that 3 hanging out over there. And just like with exponential equations, before we can change the form over, we need to isolate the expression in question. So with the exponentials, we need to isolate the exponential and then change it over to a log. And same goes here. Before I can take that log and change it to an exponential, I can't have that 3 there. I don't know where that 3 would go. Now notice here, I want you to notice there's a plus sign here. That plus sign goes with the log of base 4. Okay, of x. It just means that is positive. It doesn't dictate what you're going to do with the 3. What dictates what you're going to do with the 3 is the fact that the 3 is positive. And because that is a positive 3, now you will subtract it. Okay, so if you had a minus sign right here, you would still subtract the 3 because the 3 would still be positive. So that's like an important thing to note in case you did have a minus sign there. 3 minus 3 is 0. And if you had that minus sign, of course, you would bring the minus sign down in front of the log. We don't, so that's nice. All right, and now we change the form over. So this would be 4 to the 3rd power is equal to x. And you might know 4 to the 3rd power is 64. We've seen that a lot. So if you've been paying attention You probably have noticed that. And then the last example is natural log of x is equal to 9. And you can skip over a step, but I'm going to do a little bit of a middle step. I'm going to do it. Hey, here's a reminder that the natural log is equal to log base e. You do not need to do that step, but for a lot of people, it is nice to have the log base e, because then you can see the base, you can actually see it. You don't have to do that, but now I can see this is e to the 9th power is equal to x. Now that is what we call an exact answer. Okay, e to the 9th power. So if you are asked for the exact answer, that's where you're going to stop. If you want to do the decimal approximation, you can grab I am just using a calculator here, or you can use Desmos for this. I need to find my E button on here. Here we go. E to the 9th power. And that gives me this lovely number, 8,103.0839. Ouch. Okay, and that is the approximate or rounded answer. So mathematicians tend to like exact answers. Okay, and then we have the decimal approximation that you would get on your calculator. Okay, so that brings us to some practice problems. So pause the video and work out the practice problems. Actually work these out on your own to make sure you have an answer. For the second one, recall that if you don't see a base, then the base is 10. It's called a common log. So in the second one, that is log base 10 of x is equal to 1. Pause the video, and then when you have your work done out, unpause the video and we will go over the work and you can make corrections as needed. All right, so in our first one, we have log base 2 of x minus 3 is equal to 5. When I change that over, I will have 2 to the 5th power is equal to x minus 3. Now, you might know 2 to the 5th power, but if you don't, grab your calculator and do it out, okay? 2 to the 5th power is 32. And then we will add 3 to both sides, and we will get x is equal to 35. Okay, second problem. We have log, and then remember, if you don't see a base, it is 10. It's called a common log. So this is log base 10 of x is equal to 1. And so when I change that over, I will have 10 to the 1st power equals x, which is just 10. And last but not least, we have the natural log of x plus 4 is equal to 3. So this is log base e. Okay, might be helpful to just remember that. And so this will be e to the 3rd power equals x plus 4. And if you want the exact answer, you would just subtract 4 and you would say it's e to the 3rd minus 4. Okay, that's your exact answer because there's no rounding. And then if you need the round, whoa, don't do that. There we go. I wanted to clear it. That's what I wanted to do. Okay, e to the 3rd power minus 4, and I have 16.0855 is equal to x. Okay, now that didn't take too much time, even with the little prelude there. It took me less than 3 minutes to do those problems. Now I know that I work faster than you are probably working, but hopefully that did not take you any more than about 10 minutes or so. Okay, it should not have taken. If it took you longer than that and you're doing this from home or you're doing this on a day that I am out, then I actually want you to tell me that it took you longer and about how long it took you to do those 3 practice problems. Great. So what about strategy 2? When do we use strategy 2? Well, this is the setting the arguments equal. So we use strategy 2 when there are two logs with the same base. Now, full disclosure, just like you don't usually see exponentials with different bases or like roots that have different indices on them, you don't usually see logs that have different bases, but we want to make sure we cover all of this. So two logs with the same base on each side of the equation and nothing else. Okay, so we don't have anything else. So we have some examples here, like log x equals log 4. If you saw this, okay, you could not use this strategy to do it. You would need to use a property of logs to be able to get there. And we will cover the properties of logs, and we'll come back and revisit problems that look like that, but not for now. So you can't have something else, just two logs of the same base, one on each side of the equation, and or possibly you could get one on each side. So if you have this log minus this log equals 0, you could add a log to each side, kind of like we did with the radicals. So what this strategy is essentially saying is if you have the log on the same side of the equation, on each side of the equation here, you could just undo the log and set the arguments equal. X must be equal to 4. If log of x equals log of 4, x has to be equal to 4. Log of anything else, it's not even going to be equal. Over here on the second one, we have the natural log of x plus 4 is equal to the natural log of 5. And as long as you have that set up where you have the same log on both sides, don't say cancel the logs, and definitely don't say divide by the logs. Like there's no division happening here at all. You cannot just divide by an log. It just doesn't work that way. That's like having a square root symbol with nothing underneath it. It doesn't make any sense. But you can set the arguments equal. And then we would solve for x by subtracting 4, and we end up with x is equal to 1. All right. So that's pretty much strategy 2. Go ahead, pause the video, and check out these two practice problems. And then when you have an answer, go ahead and unpause the video and rejoin us back for the rest of the practice review. Okay, so on my first one here, I have log base 3 of x minus 7 is equal to log base 3 of 4. And I can set my two arguments equal. So I have x minus 7 is equal to 4. And then, of course, we could solve this by adding 7 to both sides. And we get x is equal to 11. In problem number 5, we have the natural log of x squared is equal to the natural log of 16. Okay, I was like thinking of something, possible strategy to use there. All right, so in this one, we would have x squared is equal to 16. Always be careful with those quadratics there. Essentially, we want to know what number squared would give us 16. And so you could take the square root, but you do need to remember that pesky little plus or minus, okay? And that is because both a 4 and a negative 4, when we square it, will give us the 16. Now, this is definitely worth checking on Desmos, okay? It's definitely worth checking on Desmos. I won't do it at the moment, but because logarithmic equations do have what are called extraneous solutions. Those are solutions that come out of the work, but are not actually solutions. So you do, it would be worth it to check the solutions on that. That took me less than 2 minutes to do these problems. So I do expect it to take longer for you, but not more than, say, 5 or 6 minutes on these two problems. All right. So I am aware that this video is getting assigned at least the year that I'm recording it. this video is getting assigned on a day where I am missing a 55-minute class. We have some wonky scheduling going on. And some of you are going to be making it up for homework because you also are going to be missing that 55-minute class. So this video just hit the 20-minute mark, and I am anticipating that you would pause the video for at most about 15 to 20 additional minutes. That brings us to a total of 40 minutes for a 55-minute class, saying that it takes about 5 minutes to get settled and get your computer booted up and find the assignment. Maybe we're talking about 45 or 50 minutes. You should have about 5 to 10 minutes left in the class period at least, okay, maybe more, to knock out your homework. So here's your homework. We have 5 problems. These are also on your in-class notes, and I also have posted them on OneNote, at least this year. Okay, I can't guarantee I'm using OneNote every year. And there's a couple of hints on this. On number 2, you will need to recall your negative exponents. And we recently reviewed negative exponents because they came up on one of your exponential equations homeworks. So keep that in mind. Okay, you might want to go back and look at that homework or look at the review for that homework. On number 4, you will need to solve a quadratic. And then in case you don't remember how to solve quadratics, you want to get everything on one side of the equal sign and factor. It is a simple factoring problem. Okay, it's a simple one. Okay, and then you can check your answers by graphing on Desmos, but you still need to show the algebra work. So you are welcome to graph these in Desmos and see where the graphs intersect in order to check your algebra, but you should be showing the work. Now, for a lot of students, like I would expect this homework to take in the ballpark of about 20 minutes. So if you finish the rest of this early, you might be able to do it all in a 55-minute class period. Otherwise, you're going to work on the homework and bring that in next class. As always, you guys know where to find me if you have questions, and I will see you next time.